let's see if we can. I'm running a lot of apps, so let's see if I can shut some of those down. That's helping, hopefully. Okay, I can see that my screen is still fairly blurry, and I can also see that the video capture device is somehow not capturing me. So let's fix that. Okay, interesting. Yeah, so I'm definitely here. We're going to start in a few moments. It's just a little bit interesting that it's not capturing my video right now, but let's... There's always something with these live streams where something just breaks. Okay, let's just see if I can add a new video capture device. Let's call that video capture device 2, sure, and let's use the Brio. And yeah, okay. Let's now select me, and let's make that a bit smaller. Okay, sorry about that, folks. It's always interesting when you're starting up a new screen. But I do think we're live, so I'm just gonna... if people are in, let me know. We're gonna get started in like pretty much a minute. It's just always good to know for sure that the stream is set up well. So, hi everyone. Feel free to chat and say hi. Especially if you're tuning in from abroad, I do think that's always just kind of fun and nice. I'll give it like one more good minute, maybe also to do like a slight bit of editing here, like my face doesn't necessarily have to be that big, we can always keep it a bit smaller. And it's also kind of nice because that way we have more screen real estate for the code, which is going to be the main thing we'll talk about today. Okay, so people are joining now, so that's good. So I'll just, I'll go ahead and get started, like basically to introduce what we're going to be talking about today. So, long story short, I have this library called Embetter. It's something I showed in a previous like whiteboard video. It's also something I've shown in a previous live stream. And it does a couple of interesting things, but I like to think it's also got some interesting nuggets of knowledge with regards to making a Scikit-learn plugin. And that's something I would kind of like to dive into today. Hopefully that can help you if you ever want to make your own Scikit-learn plugin. But also we can talk about, you know, what it's like to maintain such a package. Because believe it or not, it actually broke like today because of a dependency, which we'll also talk about. But just as a small reminder, like the way that this library works is from Embetter, there are these submodules, like from the Vision submodule. And there we've got these pre-trained large models that you can use in the Scikit-learn pipeline to generate features. So the big idea here is that even if you've got images, we can turn those images into numeric features, which you can then pass along to a Scikit-learn pipeline, let's say. And that's, you know, definitely kind of nice, because for rapid prototyping, that means you can do all sorts of fun stuff. But it also means that, you know, there's just more stuff that you can do. Like, even if you're dealing with a tabular data set that has, let's say, a text field, text can also be embedded by a large neural network, and then suddenly those are features that you can add next to your one-hot encoded features, and you can still pass all that down to a gradient-boosted model. So the hope of this library, to me personally, is that it will help me with rapid prototyping, but I have heard stories from other people that they actually use it for somewhat serious purposes for tabular data as well. So that's... you know, just it's kind of a nice little fun detail there. I'm just going to check the stream one more time. Yeah, this seems to be working. That's great. But before diving into the code here specifically, I figured it would be kind of fun to maybe talk a little bit about what it can be like to work on Scikit-learn components. Because there's actually some like small things that you can do under the hood to make the whole experience better for everyone. So we're going to see the code of the library in just a bit, but I figured I'd start by just talking a little bit about like how do you make a Scikit-learn component in the first place. So as you might remember, like in general, what you would like to do in Scikit-learn is you would like to have this pipeline. So you're going to do something like make pipeline. And then there will always be a component that does something like generate features, right? That's a component that you have. And then after that, you might have some machine learning model. So like some logistic regression, let's say. Like stuff like this is stuff you typically do a lot of in Scikit-learn. And what I'm going to be doing is I'm going to be focusing on tools that don't necessarily do the machine learning bit. I'm going to be focusing on tools that do this generating of features bit. And inside of Scikit-learn, those components are typically called transformers because they transform the data. That's not related to the transformer neural network architecture. Just historically, Scikit-learn has always referred to data transformations as like done by something that's called a transformer object. So, okay, like what do those components need? Well, because it's a pipeline, we are going to fit every single component by calling .fit on it. So data is going to go into a thing here. We're going to call .fit, and then we're going to call .transform, and then we're going to pass that transform data to the next component. So, okay, that means that if I'm ever going to make a class that does this, those are the two methods that I need to implement. So as a dummy example, I have an identity transformer object over here. And what this thing does, really, is it's just going to not do anything with the data and pass it forward. But just to adhere to the Scikit-learn API, it needs a fit method and it needs a transform method. In this fit method, I can learn from the data, which I can then use to do something in a transformer phase. So like with a scalar, like if you're doing the standard scalar thing, this would be the place where you would learn the average and the standard deviation. And in the transform step, if you were dealing with a scalar, this is where you would actually use the mean and the standard deviation to normalize your data. So far so good. Like technically, if you want a pipeline to work, this is really all you got to do. You got to have some sort of an object that has a fit method and a transform method, and it needs to have like the right signature. So like the first item that goes in is the features, and the second item might be the label. Typically, you would actually set this to none for a transformer because a transformer doesn't technically need it. But lo and behold, this is technically, this could already go ahead and work. But there are some things that you can actually do inside of Scikit-learn to just make this a little bit nicer. Because if I look at this object, right, if I've got an instance of that object over here, then this thing only really has two methods. And you can also see that the way that it's printed, it's really not showing me a lot of extra information. But what I can do is I can say, well, Scikit-learn has this notion of a base estimator, which is technically it's just a class with lots of stuff predefined for you that pretty much every estimator in Scikit-learn would need anyway. And just to give like a example of what that looks like, right? Like I can add a base estimator to this class. And the class itself doesn't look that different. But if I now were to make like an actual object out of it, oh, we get that nice UI. That's like something we get for free. The thinking is that there's a little bit of logic required to like generate this pretty HTML inside of the notebook. And that's code you don't want to rewrite for every single estimator inside of Scikit-learn. That's actually like a very core, very base thing. And that is why every estimator inside of Scikit-learn inherits from this base estimator. It just has a lot of useful stuff that you don't want to implement on every single estimator object. Now note that the estimator, like the base estimator, is very generic. So a machine learning model inside of Scikit-learn, like this logistic regression, that would also be a base estimator, just like this transformer. And for the machine learning bit, we don't care if it's a clustering algorithm or if it's a regression or a classification algorithm. They're all just base estimators. So you still get a lot of like methods that are super useful and nice. So the get metadata routing will be one, the get params, the set params. Like there's definitely more than one thing that's happening here under the hood. But I hope you appreciate that, yeah, it's actually kind of nice that if you were ever to build your own package with your own plugins, always inherit from the base estimator. You just get a bunch of useful stuff for free. But we can actually go an extra step further, which is pretty interesting too. So if we know that this is going to be a transformer, right? Like stuff will go in and we're not really going to learn a machine learning model. We're just going to transform the data for the next pipeline step. Then there is also another estimator that we can attach, or like another base class, I guess you should say. In Python, this is typically referred to as a mix-in class, but effectively what we're just going to do is we're just going to inherit from more than one class here, which is Python's way of saying, well, there are some base properties that we're going to be using, but this is a nice way for us to have like some extra methods and some extra properties just for transformers that we also don't have to rewrite. It's very similar to the base estimator, it's just a little bit more specific. And just to emphasize this a bit, we also have a classifier mix-in and a cluster mix-in and a regression mix-in inside of Scikit-learn. So if you're ever building your own regressor or your clusterer or your classifier, these again are useful items to just attach, so to say. And just to give an example of like, okay, what do you get when you add a transformer mix-in? Well, notice that right now, when I haven't added the mix-in yet, I have fit, metadata routing, get set params, and transform. Those are the methods that I've got available to me. But if I were now to attach this transformer mix-in, right, like I'm going to inherit from that as well, then I suddenly get, for example, this guy, this fit transform method. Fit transform isn't doing something particularly fancy. It's just calling fit first and then immediately transform after, so you can call that with one method instead of two. And I think set output is also something that's set with the transformer mix-in. So if you want to have the output be a Polar's data frame instead of a NumPy array, that's also something I think the transformer does instead of the base estimator. But here you do go. Like, there are these components inside of Scikit-learn that make it easier for you to construct something custom. And it's a really good practice to actually use this internally. And what I thought was actually just kind of, good taste in programming is that kind of from the get-go, there is a distinction in between like a transformer mix-in and a classifier mix-in. And you can kind of mix and match as you see fit. And that gives a lot of flexibility, and it prevents a whole lot of rewriting the same code over and over and over and over again. So if there are any questions about this, this would be a good time to ask, because I'm about to move on now to the Embetter library and how the Embetter library deals with this. But I did think like this is a somewhat more advanced topic, but I do hope that we can also appreciate just the this kind of good taste in algorithm design, like in code design, I guess you could say here. This is a nice pattern if you want to go ahead and build something custom. And also, you might hear some rain in the background. I'm in my attic, so sorry about that, but there's nothing I can do to sort of make that stop. But yeah, I'll just look briefly at the comments to see if there's like any questions that do come in. But I don't see any questions pop up, so I do think it's maybe a good time now to then move on to something that's a little bit more internal. Because I started thinking like, okay, for this library, right, like for the stuff that I'll be doing most of the time, it does kind of feel like I've got my base estimator, I've got my transformer mix-in, I'm going to be doing stuff that's kind of like Scikit-learn, so yeah, technically most of the things I'll be building, they will be base estimators and transformers. They will kind of be both. So I was kind of playing with the idea that maybe instead of having a base estimator class, maybe Embetter should have like a base encoder class. Something that's just going to capture both of those ideas and have like, and that would allow me to just inherit from one class for most of my estimators that are just going to be a little bit more specific because they're all going to be embedding anyway. And it's going to be kind of fun for me because I haven't looked at this code for like a long time. Like it's really been a while. But inside of Embetter, there is this base folder. Yeah, there we go. And there is this Embetter base class, which inherits from the base estimator and the transformer mix-in. But what this actually does for this library is it goes ahead and it implements fit and partial fit, because those are no operations for embedding models. The thinking is that embedding models, as far as the Scikit-learn pipeline is concerned, those are trained ahead of time. Like, you're not going to train an embedding model inside of a Scikit-learn pipeline. What you would like to do is you would like to reuse such a model. But it also means that all of my components, they will always have the same fit method. They will just, you can call fit, but they won't do anything. So I can just immediately return self whenever fit is called or when partial fit is called. So this felt like a pretty nice way of going about it. I didn't feel like implementing fit and partial fit on all of these embedding models, and there's actually like another like kind of convenient thing here by doing this. So what I can do is from Embetter .base, I can import this this base estimator. And if I were to do an isInstance check, like is a base estimator an instance? Actually, it's an Embetter base object, not a base estimator. But what I should be able to confirm is that a better base class that's not a instance of a mix-in, but I do believe it's an instance of. Oh wait, no, sorry. Instance works differently. Let me work towards this. Make that full screen. If I were to actually import a Embetter model, I should do it that way. So a sentence encoder, that's like the basic model that I keep on using. Sentence encoder. And just for good measure, I should show that. This is the sentence encoder implementation. So you can see that it inherits from the Embetter base model, which in turn inherits from the Scikit-learn base models. And what you can also see here, which I think is like definitely kind of nice, I have an initialization method that I definitely use. But what you don't see me do is implement fit or partial fit, and that's because I'm using this base class. But yeah, what I should be able to do now is I should be able to actually have a encoder like so. It takes a while to load because it has to do a bunch of PyTorch, but now if I were to ask Python, hey, is that encoder an instance of from Embetter base import Embetter base, I should be able to confirm that, yeah. So this encoder, that is an instance of a sentence encoder, but because this sentence encoder over here actually inherits from a Embetter base class, I should also be able to confirm that it's an instance of the Embetter base class. But because the Embetter base class on its behalf is inheriting from the base estimator, the encoder is also a base estimator. So the cool thing here is that if Scikit-learn does whatever check, like, hey, is this a transformer mix-in, or like what kind of an object are we dealing with, I am still adhering to the Scikit-learn standard here. I am still using these base building blocks to construct my own components. I can kind of just feel how much benefit you can kind of get out of that if you just treat that kind of formally. So again, this is definitely these are considerations that you have when you're trying to build a plugin library. As a user, you're not really going to be dealing with this too much. In fact, it's kind of nice that this is somewhat hidden in the background for you. But topics like this do tend to matter once you start making a plugin or to try to maintain a package. Like the experience of a library developer is a little bit different from like a library user's perspective because of stuff like this. And I did think like these details are kind of nice to just sort of show and throw out there because there are like details here that do tend to matter quite a bit. But I also, like, I'm still pretty proud of this design choice. Like, it was basically the observation of, yeah, I don't feel like implementing these methods all over the place in every single class that I have. So, okay, let's turn it into something of a base class and then reuse that all over the place where possible. That kind of felt like a good practice, and I'm, to this day, still pretty happy with that decision, I should say. So yeah, this was a somewhat advanced introduction, especially if you've never done this before. I can imagine it takes a while to like properly get this in, but I did think this was like a nice topic to at least sort of mention. Like there's more than one design choice when it comes to like writing a package and implementing a model or a pipeline, I guess. So okay, hopefully that was useful, and as a next step, I also want to give a glimpse of what it's like to maintain libraries like this, because something that was actually a little bit funny happened this morning. Like something broke, not because of me, because of something else. Before diving in that though, I am gonna wait to see if there's like a couple of questions, because there's a bit of a delay. So I do want to make sure the questions get answered if there are any. Oh, hello, Wouter. Nice surprise for my break. I'm consciously planning these sessions during lunchtime, so like the hope is of course that some people tune in during their break, but I'm happy to hear this is useful. But okay, like these are implementation details. Like when I find myself writing a library for Scikit-learn, I try to like think of ways to make my life easy, and especially if I'm going to implement lots of components, I do try to look for like a nice abstraction. And again, like I do think not having to implement this fit stuff everywhere is just kind of nice. But this morning I was kind of looking at the code, and I'm going to live code on it, so let's confirm that it still runs. And I noticed that the unit tests actually broke. So this library has like standard unit tests. They run once in a while, and I was making like a README change. And then I noticed the test suite just broke because I changed something in the README. And that usually means that I didn't break something, but something might have gone wrong with a dependency. So I had a look, there's code checks that run, and I was doing like some unit tests, let's say, and this didn't break. Let me grab one that did break. This one did. Yeah, so a unit test here broke, and I was scrolling down, and something that I thought was just an interesting hint over here is... yeah, so I'm doing something with, I'm importing Gensim over here. And then at some point it's complaining that it cannot import something in SciPy. So that's kind of interesting, right? Like so what is happening here is there's Embetter. That's my library. That library has support for Gensim. That's it's kind of an old school library, but it's definitely something that can provide embeddings, and some people use it. So I have a component that allows you to use Gensim embeddings. And Gensim on its turn depends on NumPy and SciPy. And once in a while, what I've noticed that like something that can happen is it can be the case that it's not so much anything that's breaking in my library, but it might be that Gensim is relying on an old feature of SciPy, and that's actually what's kind of happening here. Like I can read that Gensim is trying to import something in its matutils library from the SciPy linear algebra submodule that doesn't seem to be existing anymore. So I thought like, oh, that's not good. What might be the solution? So I started looking at the Gensim issue tracker. And there was an issue here that was added 2 days ago. Like I recognize some names here as well, but it turns out that, yeah, Gensim is depending on like a somewhat old feature that got deprecated in SciPy. So the fix for now is to make sure that the version number is small enough. Okay, so this is the fix that Gensim will implement. I don't think that this fix is live yet. So what I have done, at least for today, is I actually added that fix to Embetter, such that if I were to code something and if I were to sort of run that, the test suite would actually report mistakes that I make instead of mistakes that happen here. But from a library maintainer's perspective, honestly, half the time it does feel like my library is not making the mistake, but some dependency of mine has proven to have broken. And I also felt like just sharing that because it's something that people are sometimes surprised by. Typically when NumPy or SciPy deprecates something, they will have like a deprecation warning up for like at least half a year. Like they do announce this sort of thing. But it's no guarantee that all the other libraries that depend on it are able to update fast enough. It's still a lot of volunteer work, so I can't necessarily blame anyone. But what I do for other libraries that get a bit more traffic is to sort of deal with this. What I have in GitHub Actions sometimes is a cron job. So that's basically a test run that triggers every single day. And that way, if a test ever fails on a random day, I can then check, okay, which of my dependencies have released a new version? And usually that's like a really good hint to figure out what really broke. And this is, again, one of those like weird things you learn when you maintain a library that you typically aren't exposed to when you just have internal code. The downside of doing stuff in public is that other people can actually rely on it. So the outside world might use all sorts of different versions of Python and NumPy, And it could be that something breaks because of that. So yeah, I accidentally did a bug fix this morning, which I wasn't intending on on doing necessarily. But okay, nonetheless, what I did figure was going to be like pretty interesting and fun is like, okay, let's see what it can be like to actually do a PR and maybe do a feature for this library. And what I typically do for projects like this, where really I'm the only maintainer of this thing, and it has like, it has like 400 GitHub stars, so it has like some users, and I think it has like 1,000 downloads a month or something. So like, people do use it, but I do see it kind of very much as a personal project. So that means that if I have a fun idea for the project, I try to write it down in an issue, mainly so that I don't forget about it, but also such that I can always pick it up later if I feel like it. I don't like to put too much rush in this. And there's lots of ideas of like different, models to add. Like there's always more embedding models that it could be adding. And I was thinking that it might be fun to add one of these models today. Some of these models are actually way less work than you might think. And it's definitely going to be more work in the documentation department than anything else. But I did feel like maybe picking some of these ideas up, or at least discussing them, that could still be like fun for the next half hour or so. Before moving on to that, though, I do see some questions popping in. So let's see. Magda is asking, do you have some nice source that would make understanding of how to work with dependencies a bit easier? I lately couldn't implement make score with root mean square logarithmic error because of it. Honestly, like, it kind of falls into the category of the only way to sort of do this properly is to expose yourself to the problem. So I also did not read a book on how to properly deal with this. But it's also one of those problems where you understand it by talking to someone who has been exposed to the problem, or if you end up maintaining your own library. In the end, it's also like a complicated thing. That's also maybe good to remember. There's not like a simple solution to the dependency problem, so to say. So let's say that let's say that we're using NumPy and there's Scikit-learn, right? And I have a project that uses NumPy and Scikit-learn. And like Scikit-learn definitely depends on NumPy. NumPy, I believe, like SciPy depends on NumPy, and Scikit-learn also depends on SciPy. So this is great. And let's say that we're also using Spacy. It's a pretty good NLP library. And Spacy doesn't depend on Scikit-learn, but Spacy does depend on NumPy. And here's my project, right? And let's say that I only directly require Scikit-learn and Spacy, but I don't necessarily use NumPy directly. Now, in this particular case, right, all of these libraries are super mature, and they have, a pretty reasonable pool of people maintaining it. So you can imagine that if a serious bug were to actually appear here, it probably would get fixed, on a pretty reasonable basis. But then again, you can get into this awkward scenario where what happens if all the SciPy maintainers are on holiday for a month, right? Like, what theoretically could happen there? Well, then it could be that the NumPy maintainers decide to release something that's not compatible with SciPy, and that would mean that if Scikit-learn requires something from SciPy and SciPy expects something from NumPy, the whole thing just breaks down. I am paraphrasing here a little bit, of course, but it is also just kind of a hard dependency problem, especially when you've got projects like NumPy, which just everything depends on NumPy, right? And it's also why I at least notice that whenever I talk to like a NumPy maintainer or even like a Scikit-learn maintainer, they are rightfully so a bit conservative, because they are aware of the fact that if they break something, it will really ruin someone else's day. Now, there is a bit of a difference in the sense that if my project is closed source, right? So let's say that this project is not out in the open that people can download. Let's say that this is something behind walls. It's like something I do for my company and only my company. Well, then the fix is relatively easy, because you can just say, well, I want Spacy version 3.7, Scikit-learn version 4.0. And like, you can really say, I want these hard-pinned versions of all these libraries. Like, that's something you should do, probably. But for an open source package, that's way harder, because if my project that's open source says you must use this version of Spacy and you must use this version of Scikit-learn, then it also means that all the users have less flexibility. And that's also something I try to be aware of just a little bit. Like, I remember when Scikit-learn 1.0 wasn't out, and I actually took the conscious effort of not asking the Scikit-learn users, different packages I maintain, to upgrade to Scikit version 1.0 until it was out for like a year. Mainly because there might be a breaking change, and I don't want to force a user to deal with that breaking change right now. But again, like this is what's hard about dependency issues in open source land. You are dependent on other projects. And I remember, like, back when I worked at Explosion, like, Spacey, so that was actually kind of an interesting one. So, Spacey, again, cool project, check it out. But Spacey depends on a bunch of projects under the hood. One of those projects is Typer, which is a command line utility library. And Typer, depends on Click, which is, like, one way of looking at Typer is it's kind of like an attempt at upgrading the Click command line interface to support more types and like using the typing features in Python a bit more. Click is nice, Typer is super nice, but Typer is maintained by someone called Sebastian, and Sebastian also maintains FastAPI. And FastAPI is a super popular project, so you can imagine that there's this maintainer who has to sort of, on a day-to-day basis, wonder, well, which project am I going to pick up now? And if there's a broken dependency here, I cannot blame Sebastian for saying, well, I also have things to fix in FastAPI. So, again, like, no one blames Sebastian for this, but I do remember back at Spacey that relying on Typer and Click at the same time was causing some hurt. So what the folks over at Explosion did, like the maintainers of Spacey, they said, well, let's just write our own little command line util library that doesn't do everything that it needs to. And I believe it's still around. I think it's called Radically. But that way, if we depend on Radically, we no longer depend on all that other stuff. And this ended up being, like, better for the Spacey project because we've actually had a moment. I remember a few moments where Spacey wouldn't work because Click introduced a breaking change. And again, I can't blame anyone for, like, the snowball effect here, but, like, stuff like that does happen. So sometimes it really can make sense to be conservative in what you depend on. And it also means, by the way, that you don't want to depend on everything from the get-go. There's actually a detail on that that I should also mention here. So this project is using setup.py. It's not necessarily the most modern way of declaring a Python project these days. But one thing that I did declare very consciously is I made a lot of these packages optional. So you can get embeddings from a project called Spacey. You can get embeddings from a project called Gensim. You can also get them from Keras or from BytePair or from SenseDevec. But when you install Embetter, I'm not going to install all of those optional dependencies immediately. I give you the option to do that yourself. And right now, when you install Embetter, the thinking is that should be as lightweight as possible, maybe. Or like maybe some sensible defaults, but not all the things you might be possibly interested in. Because by doing that, the surface area of stuff that can break also becomes a fair bit smaller. If you only depend on a few things, then the odds of a few things going wrong is a lot smaller than, like, all the things that could potentially go wrong. And in particular, this error this morning that I was talking about, like the fact that Gensim broke, that did not affect any Embetter users that weren't using Gensim embeddings. Like, only the Gensim embedding users, which I think is a small subset, they would have been hurt by this. Everyone else could just blissfully ignore it. So one thing to consider, not only can you build a plugin such that a feature doesn't have to go into the core library, even when you're building a plugin, you can also say, well, some of the features require an extra installation step. And that can also be like a nice way to sort of keep the surface area of stuff that could go wrong down a bit. So I hope that, like, again, that, like, these are things that you only get exposed to when you actually start maintaining a library. Like, you suddenly get different concerns, and it's especially the case if the library is externally facing. So if I were building an internal tool, I would also consider that to be a whole lot simpler, basically because I can hard pin dependency versions. But that's somewhat unfriendly if you're doing it in open source land, because you constrain your users a whole lot when you do that. Let's have a quick look at time. Okay, we still have a little bit of time. So one thing that I'll just do real quick now. Yeah, let's do that. Just to show it. Like I've seen at a couple of code sprints that okay, we're gonna do open source. People want to get started with open source, and then they're kind of forced to do the whole Git thing. Like, okay, how do I get the project set up locally, and how do I set up the virtual env and all of that. But one thing that I have started doing a bit more, also because I've got like too many of these projects, is I've started using Codespaces, which is a free offering for GitHub at the moment. If you are using VS Code, you can use VS Code in the browser as well, but if you're working on an open source project, it's a free service. And you can set it up in such a way that when you click a button here, VS Code will set this whole environment up in the browser for you. But I have set it up in such a way that if I were to click that button, VS Code actually opens locally. I think I already had the window open, but it's gonna boot up in a bit. And also, like, this is very much a VS Code only thing, so I think it's a very nice and likable trick, but if you're using a different IDE, this won't work. But yeah, I'm gonna close this window because I've already got it open here on my other display. But what you're looking at here is basically the code is running on a server from GitHub, but the experience is like as if I'm building this locally. So if I want to keep virtual environments separate, and if you're just getting started, like getting familiar with Git, this is actually kind of a nice way of getting started, I would think. So what I've done here, just to show, is I have added that Gensum fix that I mentioned. So I'm saying, if you're going to be using this library for this particular version, SciPy has to be less than 1.13.0. And I think there's actually that's actually kind of I can improve this code. So what I did this morning, just to confirm that the test would run, is I added this constraint to the base packages. But as I'm thinking about it right now, these base packages are such that if you install this library from the get-go, all of these things are going to be installed on your behalf. And I actually think that because this is a Gensum-only concern, I can actually say, well, let's only require that of people if they actually install Gensum. Like if they require the Gensum stuff. Then and only then do I require SciPy be less than a specific version. Because then and only then, Gensum will break. That's actually a better idea. Another change that I want to make, but that's more because I've been using this library for over a few years now, and I've always just been kind of annoyed by this. But I always want to use sentence transformers in the end. Like that's the main thing I always definitely go for. And I also find myself that that's the main thing that I advise people to really consider. For most use cases, this is just kind of the library to use for now. So, maybe it should be a base package instead of a optional dependency package. Because you pip install Embetter, and then you do want stuff to just kind of go ahead and work. And right now, you install Embetter, and then it tells you, oh, if you want to use a sentence encoder, you got to restart your environment and pip install this extra thing, and otherwise it won't work. And I've just found that to be just slightly too annoying. So I'm going to upgrade the sentence transformers dependency to a base dependency, I think. That does mean that any reference to sentence encoders needs to go away. So I'm updating my setup.py file to reflect that. I think there was something... so sentence, that's the only place, right? Okay, so that looks pretty good. Git status, git add setup.py. Let's add the change in here. So sentence transformers upgrade. Good. Okay, so then this is a PR that's looking pretty good, and that's something we can sort of throw out there. But I think the next feature that I would just like to add, and again, what I'm about to do is more of a UI thing, but I do think it's just kind of nice to show what are things that you can consider to make life for users easier. So I might have already mentioned that the main library I like to target is sentence transformers. Right, and this is their This is their documentation page. It's a bit old, but it's still pretty good. Like they're using a different framework than I would use these days, but the information here is definitely still solid. But one thing I've noticed like a while ago is they added support for these models called Matryoshka models. Yeah, these Matryoshka embeddings. And these are just a little bit interesting in the way that they are designed. So normally, what you would have, if you're training a neural network, let's say, let's keep OBS in view. Yep. So normally what you would do is if you're training a neural network, you would have like, in the case of sentence encoder models, right? You would have like some sort of data set where you've got one text and you've got this other text. So text 1 and text 2. These are both going to be embedded. And, some sort of a vector goes out over here. And then we compare that to a label, like it's a 1 or a 0. They're similar or they're dissimilar. And it's looking like I need to go to OBS and move my face a bit, because otherwise you cannot see the drawing as well. But what happened here is there's an embedding model here, an embedding model there, and the labels here via the gradients would update both of these embeddings. But what Matryoshka does is a little bit different. What Matryoshka is saying, well, let's make multiple embeddings. Like conceptually, there's details here, but conceptually you could say like, we could pretend that both of these embeddings, these both output like a big array, but we can attach multiple loss functions here. Like we could say that we have a loss function just for the top half, and we have a loss function for the whole embedding. Something you could do. So then there's loss 1 bit, and then this is loss 2 bit. So we're comparing the first half of both embeddings and the second half of both embeddings. Both give us a loss, both give us a gradient update, and that allows us to update all of these components. But the interesting thing then that you get is eventually you get this embedding model where, I don't know, like the top half has like one loss function that's attached, but this part of the embedding will have 2 loss functions that have been attached. So you can kind of hopefully feel that if the top half doesn't summarize most of the information, it actually gets punished more. So that's kind of doing a principal components kind of a thing while training. You're basically forcing the embedding to be shrinkable. Like you could say, like maybe if I only want like half the if I only have space for half the information, let's make sure that the top half does contain most of the information that I might need. And if you read this page, there's actually like a couple of really interesting benchmarks that they do, where they show that if you use this Matryoshka learning trick, that you actually maintain a fair amount of the information of the embedding, even when you only use a few dimensions. And I think the example here is they go from like something 760 down to like 64. And if you look at the loss where they just don't use the Matryoshka style of learning and they compare that to the Matryoshka style of learning, not only is there like a decent uplift here, but there's definitely like the loss between the highest point here and the lowest point is definitely smaller than what you see with the orange line. So, this is just kind of cool. You can choose in hindsight if you want to store more or less data in your embedding database. And to me, that kind of feels like a very convenient trick. So I figured, why not make this a first-class citizen? This might be like a fun thing to add to the library. And I already support sentence encoders, so I might be able to do something clever with that. A trick that people aren't necessarily aware of, but something that I can do to make the implementation of this fairly simple. So if you go to Embetter, and if you go to text, you will see that I've got this sentence encoder over here. So this is using sentence embeddings. This is basically the sentence encoder. This is using the sentence transformer library under the hood, so you can see that I'm saying, look, there's a... yeah, so these are all the settings that sentence transformers needs from you. Let me put it that way. But sentence transformers can also do images, for example. So I also have this clip embedding over here, this clip encoder. And under the hood, it is really using sentence transformers. But it's just that it's got this, I guess, different setting, you could say. Like, the setting is just a little bit different. The main thing that's different is the name that really goes in, because that's telling sentence transformers which model to use under the hood. So theoretically, I should just be able to say something like, and I'll probably not be able to wrap this up during this video, but I should be able to do something like, and let's make it a bit smaller, but maybe I should be able to do something like Matryoshka encoder, and that's also still going to be an Embetter base model. But then when I initialize it, I'm going to need a name and let's say some keyword arguments. And this should then return. I could also make this into a function, but let's do it this way. This is going to return a sentence encoder, but the name is going to be equal to the name that's being passed in. But the default name is going to be a Matryoshka model instead. And I think, yeah, this is the one that I could go ahead and pluck. So the only thing that this object is really doing is it's picking a sensible default, such that if you don't, so you can still customize it fully by going into this this full sentence encoder that we've got over here. But what I can also just do is say, well, for most intents and purposes, if there's ever a user interested in playing around with a Matryoshka encoder, well, then 9 times out of 10, they're probably just interested in a specific setting from the sentence encoder. And from a developer experience perspective, this might actually make some sense, simply because this sentence encoder has so many different settings and also so many different models to pick from, that maybe I can also help myself and any users by saying, well, let's be a little bit opinionated. Let's just say there's a class of encoders that's going to be useful. And the main thing that the user then needs is not have to remember this string when they're using the sentence encoder. This is a relatively light feature, right? Like, I'm not suggesting that this is going to do something mega complex. You could just also pick up this name online and go with the flow. But I do think that this is an, this is also something that you can do to make life easier for people trying to play with embedding. So I do think that this might actually be a fair thing to consider. So I'm just going to add that. I'll do the testing later because we're running out of time. But this is, I think, a fun idea as well. Something I will also probably pick up when this live stream is done. But yeah, that's also something you can do in the library. You can also just say, well, the main point of some of these components isn't so much to do something novel. The main point of these components is to make life easy. It's kind of like a nicer UI, kind of a syntactic sugar kind of a thing. So that was, I think, also something fun to just briefly kind of show. And I'm looking at the time a little bit, and it does feel like we might just pull this one a bit short, because it does feel like I've said a bunch of things that give good food for thought. And while I could, do the details, write the docs and stuff, I can also imagine that's not the most interesting thing to watch as well. So maybe what I'll do just for now is just say, well, this is like the main thing I wanted to talk about and just kind of show. Like when I design plugins for Scikit-learn, this is kind of the pattern, the thoughts that are in my mind, and also the concerns that I typically have. So hopefully that was useful or insightful. Do let me know. But the main, so there's also an announcement that I can do now that will be cool to do, but it will also be good to just get questions in first before I announce the big thing. So let's just check if people have questions. So it does seem relatively quiet. So that means I'm able to now move on to something that's a little bit more of an announcey thing. So we're still definitely experimenting with like stuff that we can do that's useful for the community. And so far, some of my colleagues are also enjoying this because we get feedback in, and that's definitely going to be useful when we're working on features. But we've also noticed that it's still like a lot of Vincent is doing the talking, and that's, I like to think I'm good at explaining. But maybe it'd also be kind of nice to give the stage to some other people that also just have great ideas. We are trying to celebrate an ecosystem here. So with that in mind, I am happy to announce that we are also going to be starting a podcast. The name of the company is Probabl, and we were looking for a good podcast name. And we came up with Sample Space. The point of Sample Space is that we're going to give a space to sample great ideas from the ecosystem. So we'll be talking to people that are working on somewhat experimental tools. We are working with people who've been working on interesting technical problems. But Sample Space is going to be an attempt at making a very solid technical podcast that's a bit long form, where we kind of hope to give just a little bit more of a spotlight to ideas that otherwise might be, not getting the attention that they deserve. So the teaser is out right now. We are going to release the first episode next week. Also, for that podcast, we are definitely open to suggestions. If there's people that you would really like me to interview, definitely let me know. But I'll still be doing this live stream. We're also still going to be producing videos and stuff. But we are definitely also very excited and eager to try to give this podcasting thing a try, because we are also interested in hearing other voices. And I also don't mind interviewing interesting people. So we're definitely looking forward to that. We're not really sure how often the podcast is going to happen. We're going to be aiming for once or twice a month. It depends a bit on whether or not people are on holiday and stuff, of course. But the name of the podcast is Sample Space. I'm going to be releasing the teaser trailer more formally on the socials in a bit. But if you like some of the stuff that we're working on so far, we really hope that people find that interesting as well. That's the final big announcement I did want to make right now. I'll be online for another 5 minutes just to make sure that there are no more questions coming in, but I hope that this was an interesting exercise and getting a little bit of a perspective of some considerations that you might have when you build a Scikit-learn plugin. So these are there's some thoughts I hopefully was able to share that I would have loved to have known beforehand before diving into this ecosystem, but it still boils down to taste and understanding the core of the library. That's still something that's required. All right. It seems that people are sort of returning from lunch and going back to work now. The chat seems a bit quiet. And we are on Apple Podcasts and on Spotify, and there should also be a bunch of others. I think if you can't find us on your favorite player, do let me know though. It's a small minefield to make sure your podcast is found, but if you can't find it, I do want to know about it. But cool.